To use calculus to find maximum area of minimum materials needed. That should be an or there. Find maximum area or minimum materials needed. Example number 1. When 30 orange trees are planted on an acre, each will produce 500 oranges per year. For every additional orange tree planted, each tree will produce 10 fewer oranges. The more trees you put together, the less they will yield. So in this case, 10 fewer oranges per tree for every one after what's already been put down is planted. How many trees should be planted to maximize the yield? How many trees? At what point should we plant no more trees? Here comes the solution. X is going to have to be the number of trees beyond 30 that are planted. You'll have several problems like this during the week. Anything above what is already there, whether it's an artist selling paintings, a sculptor selling sculptures or statues, you want to find out how many they can make without losing money after a certain point. X would have to be the number beyond what is already there. Create a function for the number of oranges. So you'll have oranges and then of the value x. Oranges of x is going to have to equal something. Number of trees, that's a given. So the number of trees and then the number of oranges per tree that are going to be grown, which is the yield per tree. That's in general. Now you have to go back and put it in terms of the number of trees algebraically and the yield per tree. So we already have 30 trees. And the number beyond 30 is going to have to be x. Now each one was yielding 500 oranges before. So you have 500 oranges per tree, but there are going to be 10 fewer oranges for every tree after the 30 that you plant. So it only makes sense that you start with 30 plus x. That's the number of trees total. And then 500 per tree and the number of oranges grown, but it's going to go down 10 for every tree that you plant after 30. So that's the above 30, and that's 10 less oranges per tree. Now expand it out by multiplying. 30 plus x, then times the quantity 500 minus 10x. When you multiply that out, basic algebra 1 stuff, you have 15,000 plus 200x minus 10x squared. Sometimes there's a propensity to put the x squared first and then the x second and then the constant last, but in this case if you do that you have a negative on the x squared and it just doesn't look right. So next we're going to have to find the first derivative. So oranges of x is 15,000 plus 200x minus 10x squared. The first derivative is 200 minus 20x. And now you're going to have to solve for x. So the first derivative is 200 minus 20x. Set that equal to 0. Move the 200 over, change the sign, and divide by negative 20. X would equal 10. Now find the second derivative so we can figure out if that was a maximum or a minimum. The first derivative is 200 minus 20x, so the second derivative would have to be negative 20. And since that's a negative sign, that means x equals 10 is a maximum. Now don't stop now, because anytime you solve for x and you get a value, chances are you have an urge to just end the problem and write x equals 10 and you're finished with it, but that's not the case in these problems. The answer goes as following. X equals 10 more than 30 trees should be planted. But you have to put those two together. Thus 30 plus 10 is 40. If you plant 40 trees, you're going to have the maximum yield. If you plant 41 or anything thereafter, then it's going to be rough going. An artist can sell 20 copies of a painting at $100 each. But for each additional copy she makes, the value of each painting is going to do something. Is it going to increase or decrease? Probably decrease. The more you have out there, the less value it's going to have. Will go down by $1. Thus, if 22 copies are made, each will sell for $98. That's just an example. That's not something that we're actually going to use. It's just to illustrate what happens. So at 22, you've gone 2 over what you already have, so that's $2 instead of just 1. So you're selling each for 98, and so on. So if you sold 23, they would be worth what? 97. How many copies should she make to maximize her sales? In other words, at what point should she quit making the painting? How will the total sales be figured? That's what you have to compute first. Sales equals the number of copies times the price per copy. That's just a very basic equation. However many you have, price per copy, total sales. Let X be the number of copies beyond 20, just like we had the number of trees beyond 30 in the last problem. So the sales is the number of copies times the price per copy, but in this case, we have 20 paintings already, but we're going to have to figure out an amount over that 20 that we can go. The original price is $100, but for each copy after that, it goes down by $1. Notice that there's no coefficient written here because it's 1. So that's really $1 X. Now expand it out by multiplying. You start with 20 plus X and 100 minus X, and end up with 2,000 minus 20x plus 100x minus x squared. You have to simplify this part here. Don't leave it unsimplified. So you end up with 2,000 plus 80x minus x squared. What must you do next? Find the first derivative. So S of x, sales of x, equals 2,000 plus 80x minus x squared, and you're finding the first derivative, which means this is going to go, this part stays, bring this down, multiply by the -1, and reduce the exponent to 1. And there it is, 80 minus 2x. Now do what? Set the first derivative equal to 0. Sales prime of x equals 80 minus 2x. So set that equal to 0. Move the 80 to the right, change the sign. Divide by -2. And you'll come up with an answer of x equals 40. Now find the second derivative to verify if that's a maximum. S prime of x is 80 minus 2x, so when we find the second derivative, you're just left with the -2. So x equals 40 is a maximum. Now the answer, she should make x equals 40 more than 20 paintings. 40 more than 20 paintings is a final answer of what? 60 is it. 60 paintings. Anything after that, she's going to lose money. Here's example 3. This is about area. This is a practice problem. A garden has 200 pounds of watermelons growing in it. Every day, the amount of watermelon increases by 5 pounds. They have how many pounds to start with? 200, and every day the amount of watermelon increases by 5 pounds. At the same time, the price per pound of watermelon goes down by 1 cent. If the current price is 90 cents per pound, then how much longer should the watermelons grow in order to get the highest price? You're going to have to let x equal the number of days. And there will be 200 plus 5x pounds of watermelon. You start with 200, and then there's going to be 5 more each day, and the days would be x. So there's your starting pounds, and the 5 pounds added per day. And of course, x is the number of days. The watermelon will be valued at 90 cents to start with, and then it's going to go down 1 cent per day. So remember that x is the number of days, 90 is in terms of cents. If you're going to put 90 in terms of 90 cents, as in a whole number 90, then make certain you don't put 0.01 beside the x. You cannot have two different formulations of cents. And notice that there is no coefficient here other than an unwritten -1, because it's 1 cent per day that it's going down. Had that been 6 cents per day that it goes down, you would have seen a 6x here. Now create a function for the price. Price, P of x equals the 200 pounds plus the 5x extra each day. That's one quantity, multiply it by 90 minus x. Pounds and price per pound. So if you expand it by multiplying, you're going to come up with the following. 18,000 minus 200x plus 450x minus 5x squared. Simplify the middle, come up with 18,000 plus 250x minus 5x squared. And now find the first derivative. 18,000 plus 250x minus 5x squared. The first derivative is 250 minus 10x. And set that equal to 0. So 250 minus 10x is the first derivative. Set it equal to 0. Move the 250 over. Divide by -10. And come up with 25. Now find the second derivative so that you can test. The second derivative is -10. So that means that the x equals 25 is a maximum. So the answer is the watermelons will get the highest price in 25 days.